grade 11s, we're moving on to a new section today, and that is analytical geometry. Now, analytical geometry is part of paper 2, and it's probably one of the nicest sections of paper 2. It's a section that you can work really hard at and that you can practice very well in, and therefore build your confidence and do really well in this section. So I like it a lot. I've divided this section into a couple of topics. The first couple of topics should be pretty much revision of grade 10, things that we know but have probably forgotten. And then we only have 1 or 2 extra things to add in as part of the grade 11 curriculum. So the first couple of topics will be grade 10. We still have to revise them though, because it's these basics which get us the nice easy marks in paper 2. So this video is on topic 1, which is revising the distance and midpoint formulae. So let's have a look. My first box here says remember the following formulae. Now don't forget to push pause, and unfortunately in this section it does take quite a bit of time to copy down questions in that. But don't forget that all of these notes we're making are building our analytical geometry knowledge for grade 12. So we've got to make good notes in this section, because in matric there's only one tiny new thing we do in analytical geometry, and we don't really revise this stuff because we don't have time. So do make sure that in this section we take really good thorough notes. So hit pause a lot and copy down. So topic 1, distance and midpoint questions. Now this first block says remember the following formulae. Now these are all on your formula sheet. So we do know them from last year, and the distance formula is the square root, and it's x number 1 minus x number 2. Sometimes you swap those around, so you might say x number 2 minus x number 1, because the reality, it doesn't matter what you subtract. Now why doesn't it matter? Because you're going to be squaring it. So ultimately it doesn't matter whether the answer is negative or positive, so because it gets squared. So that is the distance formula. Again, it's on your formula sheet, so you don't have to remember it, but just make sure that you copy it down correctly. Then what's our midpoint formula? Our formula sheet says this. It says midpoint, which is capital M, and it says if you're finding the midpoint between 2 points, you add the x's together and you divide by 2, and for the y coordinate you add the y coordinates together and you divide by 2. Now that's how it's written on your formula sheet. Now I don't particularly like the way that that's written, because I like to use an equation. So what happens if I have my midpoint? So when I think about it and work with it, I prefer to work with it like this. The x value of the midpoint is add them together and divide by 2, and the y value of the midpoint, capital M, is add the two y values together and divide by 2. Now that green is not given to you on your formula sheet. Only the light blue is given to you on your formula sheet. So you've got to be able to take the light blue and make an equation if you need to. And I'll show you in one of the examples why I prefer the green version of doing it. Right, so that's pretty much what we should know from grade 10. These questions are just now going to revise how they can ask it to us. So let's start with some easy ones. First easy one is a distance question, and it says determine the distance between these 2 points. So distance, now when we do distances and gradients, we like to use subscripts to explain what distance we're working out. Now here it doesn't matter because I'm only working out one distance. But in our later lessons, we're going to start doing big questions, and sometimes you calculate more than one distance in a question, and then sometimes you get lost. So we use subscripts, which are just these letters, subscripts meaning, kind of below, not a superscript. Like an exponent would be a superscript. We use subscripts to explain what distance we're doing very often in your more complicated questions. Now literally we're just going to plug into the formula. Now it doesn't matter if you put C's x coordinate first or D's. So I'm going to go C minus D, don't forget it's x minus x, plus, and y minus, now don't forget this is y minus negative. So this is where people go wrong. This negative is part of the formula, and then the y value is in itself negative. So often what we do when we're getting lazy is we actually, instead of writing minus 10, we just work it out in our head and write plus 10. Now there's nothing wrong with that. Now the most important thing here is that I don't want to see any working after this really. The marks in this question are for did you substitute in, and then did you work out the answer. So you have to show me. We don't really have time to waste showing working that we didn't need to know. So personally, I would just work out what's under the root sign on my calculator and I'll write my answer. Now just be careful, the root of 180 is not the simplest way to write it. So there's two ways to give this answer. So either you can give it as 6 root 5. Now I just use my calculator. We should know that from exponents. That is simplest surd form. Now if they don't ask you for a specific format, you are welcome to give it in simplest surd form, or you're welcome to give it to 2 decimal places. It doesn't matter, but just make sure you read the questions carefully, because sometimes they actually specify. So if I change it to decimals, which is S arrow D on your calculator, and round it off to 2 decimal places, it would be 13.42. Now just to reiterate, I would give you a mark for substitution into the formula and for answer. So you don't even have to show the root 180. So definitely don't waste time writing down working that you don't need in an exam. Okay, let's move on to the next one. Determine the midpoint of CD. Well, great. The x value of the midpoint, again, you don't have to do it like this, but if you want to do it separately, is you add the two x values together and divide by 2, and the y value of the midpoint is add the two y values together and divide by 2. So here I get 4 divided by 2, which is 2, and here I get 2 take away 10 is minus 8, divided by 2 is minus 4. So determine the midpoint. Don't forget that the midpoint is a coordinate. So the coordinate is 2, negative 4. Now in this particular example, I used my separate formulas. There would be nothing wrong with me rather saying, instead of using my separate formulas, just saying it's negative 1 plus 5 over 2, and it's 2 plus negative 10 over 2. That could be your working out, and then I'd go to your answer. In an example like this, basically it's 1 mark for 2 and 1 mark for negative 4. So how you show your working out is entirely up to you. You could also do it in your head, and I wouldn't mind. It would be a 2-mark question. Right, so those are the basics. So let's move on to things a little bit more tricky. Next question says, calculate x and y if m is the midpoint of AB. So this is a more tricky question only because I've given you some of the midpoint and you have to work back to x. So here is where you have to work with the formula. The x value of the midpoint is add the two x's together and divide by 2. Simply because I know the x value of the midpoint, it is 2. So 2 equals negative 2 plus x over 2. So it's actually like a working backwards question, so I need an equation. Now if I multiply by 2 on both sides to get rid of the denominator, it's 4 equals negative 2 plus x, and then I add 2 to both sides and I get 6. The y value is a lot easier simply because it was the y value of the midpoint. So I'm going to add my two y values together and divide by 2 like normal. So that's 18 divided by 2, which is 9. So I found x and y. But if I didn't have this kind of separate equation formula, it would be very difficult for me to work out x because I was actually kind of working backwards. Okay, now a more difficult distance question. Determine the value or values. Now whenever they say that, it makes me think there definitely is going to be more than one, of k if the distance between p, which is 2, negative 3, and q, which is k5, is root 80. So this is a typical working backwards question because they've given me the distance. So how would I work out the distance from P to Q? I would use my formula. And the formula is the x value of 1, so it's 2, minus k squared, plus negative 3 minus 5 squared would be the distance. However, this time I know the distance. The distance is root 80. Now, one of the things making this particular question ridiculously ugly looking is the square root. Now, because I have a square root on both sides, why don't I just square both sides of the equation, which we know I'm allowed to do from surd equations, and then basically the square roots disappear. So if I square both sides, this is simply 80, and this is just 2 minus k squared, plus now negative 3 minus 5 is negative 8 squared. Now there's multiple ways to solve this equation, but personally I prefer to just solve it like a normal quadratic equation. So I'm going to multiply out 2 minus k because it's squared. Don't make the mistake of distributing the square. We're not allowed to do that, please, 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 because there are two terms in the bracket. So I need to do a binomial times a binomial, and negative 8 squared is 64. Now this is not the only way to do it, but it definitely is the easiest way to ensure that you don't make a mistake. So 2 times 2, if I multiply this out, 2 times 2 is 4, minus 2k, minus 2k, plus k squared, plus 64. So if I kind of neaten this up a bit, this is a quadratic, so I'm going to make one side equal to 0, so this is k squared minus 4k. 4 plus 64 is 68, but minus the 80 gives me minus 12. And so I'm going to factorize, and as predicted, there's more than one k value probably. Now I'm going to go with minus 6 plus 2, because that'll give me negative 4. So I get k equals negative 2, or k equals 6. So the moment they ask me value or values in brackets, I start to think there's possibly two values. Now again, that's not the only way to solve this particular equation, but it is probably the way that makes the most sense to most of us. Now I just want to explain to you why there's two answers. This question said that there's a point. Now if I draw this very roughly, the point 2 minus 3, let's say it's about there. And then it said that Q, so there's 2 minus 3. It said the point Q was at K5. Now, 5 will be somewhere up here. Now, what it's saying is that the distance is root 80. So we landed up getting K could be 6. So this would be maybe like 6, 5. Or K could be minus 2. So this would be minus 2, 5. Now, what's actually happening is that you could go root 80 that way, or you could go root 80 that way. So basically, it's like a little isosceles triangle, and that's why there's two values. Because yes, the y value had to be 5, so the y value meant that the point had to be somewhere on that level, but I could go left to that level, or I could go right to that level. And so that's why there were two answers. It's always nice to see a picture of what's going on. Right, let's have a look at example 5. Example 5 says P, Q, R, and S are vertices of a parallelogram. Now we're going to be doing quite a lot about a parallelogram later. So let me quickly draw this for you so that we can have, now we never draw completely accurately, but we try to draw so it kind of makes sense. So negative 4, 7 would be about here. So this is P. Q, which would be 4, 5, that would be lower, so that would be Q. 0 minus 1 would be somewhere down there, which is R. And the first important thing is that we always label parallelograms in the order in which they are attached. So this is P, Q, R, S. It means that the diagonal, not the diagonal, sorry, the sides must go from P to Q to R, and then S must be somewhere over there or something. Because remember, a parallelogram, now I haven't drawn this accurately, oh that looks terrible. Let me draw it a little bit more accurately than that. Remember, a parallelogram has two pairs of opposite sides parallel. That looks a little bit more believable, but still not great. So don't forget that these two sides must be parallel, and those two sides must be parallel. So my drawing isn't particularly wonderful, but anyway. Question A says, determine the point of intersection of the two diagonals. So that diagonal and that diagonal. So I want that point of intersection. Now this is a very, very important concept in a parallelogram, which is going to come up again and again and again. The diagonals of a parallelogram bisect. Very, very, probably the most important thing about a parallelogram. The diagonals of, now remember we call a parallelogram a palm for short. The diagonals of a palm bisect. Now the word bisect means cut in half. Now why is that important? That is going to come up numerous times over the next couple of weeks. That's important because bisect means cut in half, meaning this side is equal to that side and that side's equal to that side. Now notice I haven't said these diagonals are equal. So you'll notice that these halves aren't all equal to each other, but each diagonal is cut in half. Now why is that important? Because this diagonal will meet the other diagonal at the midpoint of both. So therefore, the diagonals intersect at the midpoint. The diagonals intersect at the midpoint of both of them. So I don't have to solve some simultaneous equation here or anything to find this point. The diagonals will always intersect at the midpoint. Now I know that P is negative 4, 7, and I know that R is 0, negative 1, which means I know those 2 points. So can I find the midpoint? I absolutely can. So my midpoint is add the x's together and divide by 2, add the y's together, and you'll notice I didn't bother writing plus minus 1 because I know that plus minus 1 is just minusing 1. So my midpoint will be negative 4 divided by 2 is negative 2, 6 divided by 2 is 3. So that is the point at which the diagonals intersect. Now that's really useful, that whole concept is really useful, but it's most particularly useful in our second question, which is question B, which says, can you therefore work back to the coordinates of S? So let me just fill in that Q is 4, 5, and I now know that M is negative 2, 3. Now there's multiple ways to work backwards to S. What is one of the ways? One of the ways is to say, right, this is the x value of the midpoint. So it will be equal to the x value of S plus the x value of Q, which is 4, divided by 2. So I therefore know that negative 2 is equal to the x value of S plus 4 over 2. So I would multiply by 2 on both sides, and I'd get negative 4 equals the x value of S plus 4. And so I'd subtract 4 on both sides, and I'm just going to go up here. The x value of S will therefore be equal to negative 8. So this is one of the ways to do it. I will show you a different way in a second. How can I use this? Well, 3 is the midpoint of the y value of S and 5, because that's the y value of Q. Divide by 2. So again, multiply by 2 on both sides, get 6. Y value of S plus 5. So my y value of S is 1. So what is the coordinates of S? S is the point negative 8, 1. Now, that is one way to work this out. This is definitely not the easiest way, and so this question is going to come up multiple times, and I'm going to start working with the second way, which is by far the easiest way. The reason why I wrote this example like this is because I wanted to very clearly work with the idea that the diagonals of a parallelogram bisect each other, so they cut each other in half. Now, what's the other way to do this? So let me erase my working out of negative 8, 1, which we now know is the answer. What is the easier way? The easier way is to do this by inspection. Now, by inspection means the following. I'm going to use a bright color. If you have a look at how do you go from R across to S, because those lines are parallel, I must have gone across and up. Now I went across from 0 on the x-axis to 4 on the x-axis, so that went up 4. Then on the y-axis I went from negative 1 up until 5, so that went up 6. So that's how I went from R to Q. So that's exactly what I have to do to go from S across and up to P. So I must add 4 to S, and I must add 6 vertically, and I must get up to P. So if I land up at negative 4, how do I go backwards? Well, this is 4 units. If I think I'm working backwards, I must minus 4. So this will be at negative 8 on the x-axis. And I added 6 to go up. So if I'm working backwards, I must minus 6. And 7 take away 6 is 1. So that's the other way to do it, which is why a question like B would be 2 marks, 1 for each coordinate, because you can actually draw yourself little dotted lines to figure out how to move between the two sides of the parallelogram. Now we're going to practice that idea multiple times before the end, and hopefully we'll feel more and more comfortable with it. Now let me just show you another way, exactly the same concept. Why did I have to look at R and Q? Could I not go from P to Q? Well, that would have gone across and down. Now, you would have gone from negative 4 all the way up to 4, which means I need to add 8. And down from 7 down to 5, which means minus 2. So that means to go from S, I must go down 2 and across 8. So this was across 8 and down 2. So if I landed up at 0, how do I go back? I must have subtracted 8, and I must go up 2 from negative 1, which gets me to 1. So there's 3 different ways to do this question. But again, we'll practice a lot and we'll get more comfortable with it. So last question for practicing distance and midpoint. A and B are equidistant from P. Determine the values of A. Okay, now let's quickly draw ourselves a picture for what this means. Negative 1, negative 1. Remember, we don't draw accurately, but basically P, which is negative 1, would be somewhere around there. Now, A negative 2 means that somewhere where Y is negative 2, so if this is negative 2, somewhere there's a point A, and somewhere, and B2, not somewhere, B02, which is there, B02 is the point B, and it says A and B are equidistant. Now, equidistant means the same distance. So A is the same distance from P as B is from P. So there's a distance from P to B. I'm going to call that distance PB. Do you notice that I can actually work out that distance because I have all the coordinates? Now, this is apparently the same distance as, now, for example, I'm going to put A here. I don't know where A is, but let's pretend it's there. So what it's arguing is that this is the same distance. Now, why is it said the values of A? Exactly how we did in the previous question, you could move either way. So A could be to the left or to the right, as long as it has a Y value of negative 2. So basically, all of those distances are the same. So what's our first thing we need to do here? Well, I don't know the distance from P to A because I don't know A's coordinate. But I can work out the distance from P to B. So if I work out the distance from P to B, it's on my formula sheet. We don't bother writing down the formula. We generally go straight to substitution. So it's negative 1 minus 0 squared plus negative 1 minus 2 squared. Again, we don't show any working. We just put that in our calculator and we get root 10. Now notice I don't write that in third form because I'm going to be working with that because I now need to work backwards to A. So I don't want to work with, I am going to leave that in third form. I don't want it in decimal form because I'm going to work with that in a moment. So I don't want to round it off. So what is this saying? Is it saying that this distance is root 10 and this distance is root 10. So the distance now from P to A must also be root 10 because A is equidistant. So that means, and I'm probably going to run out of space here, I've written so much. So that means root 10 is equal to the root of, now it's negative 1 minus A, I don't know what that is, plus negative 1 minus 2, so it's actually plus 2. Now, again, we've done this before, and so I'm immediately going to square both sides so that I just get 10 is equal to negative 1 minus A multiplied by itself, plus, and negative 1 plus 2 is 1, so 1 squared. Now I've run out of space, so I'm just going to go up here. So 10 is equal to negative 1 times negative 1 is 1 plus A plus A plus A squared, and then plus 1. And again, this is just a quadratic equation. We've solved this before. So this is A squared plus 2A, and 1 plus 1 is 2, but minus 10 is minus 8. So don't forget, if you're struggling to factorize, you've got the formula. And I think this is going to be plus 4 and take away 2. So I get A is 2 or A is negative 4. Now if I look at my my picture that I'd kind of drawn for myself, this kind of makes sense. So what they're arguing is that either this is 2 or this is -4, which even though my picture isn't accurate, that does look entirely plausible. And so I've determined the values of A. So that's pretty much everything we should know about the easy distance questions, and then this is definitely a very difficult distance question that we might remember from grade 10. So that's the end of topic 1.